Now, in today's session, this is going to be crisp session. First of all, here we'll do a lot and lot of coding. Uh, but for that purpose as well, like first 15 to 20 minutes is something we need to give to the intuition first of all. Uh, in this session, we are going to discuss about a very important uh, platform where you need to have an account on first of all. And the platform, can anyone make it a guess? Those who have gone through the title, those who know, yes, Hugging Face, not Kaggle, Hugging Face, right? So there is a platform called as Hugging Face. We'll discuss about that. We'll discuss what are the things that we have in Hugging Face and how we can utilize all these functionalities. Okay, and yep, that's the main agenda of this session. And at the end, I'll give you a decent level assignment as well, where you need to uh, take any of the Hugging Face model and do some task on top of it that I'm going to share it with you.
Hello, sir. Good evening.
Good evening.
So, can I ask a question?
Yes. Okay, go ahead.
So, in the project 8, you have said that in the assignment we should load the Oxford flower dataset, right?
Mhm.
It's not downloading, sir. Is
Okay.
I'm only facing the problem or any other? I'm not understanding, sir.
Okay. So that data set, I have also attached the codes that will help you download the data set, and they were working codes. Okay. Yes,
Oh,
someone did it. It works. Yes, the codes are already attached. What I'm going to do, let me brief you in a moment as well. What exactly was the assignment? So in the assignment, where exactly can I find the resources? Uh, they are there on the portal. So just give me a minute. Let me go to the portal and download the assignment. Just give me a second, okay?
so yesterday I tried. It was downloading and working, but today, when I'm trying to submit the assignment, it's not working, sir. So, what's the issue? It can be.
Okay, I seriously don't know what can be the issue.
Okay, sir. Okay, sir.
Codes are working. It should be the same, but let me give me a minute. Let me see like if I have attached the code or not. Okay, so let me present my screen with you on a minute.
You have attached the code at the bottom of the assignment section, sir.
These are the codes that are already attached. If they are giving you some sort of error, you can do some research on the internet, like what is the issue. Because here as well, I have also added couple of try and accept block if it is downloading or not, and it is downloading it. Okay, if not this way, you can also go to the internet and get this Oxford Flower 102 dataset. You can get it from some other source as well. You can also load it from there. The main agenda is you need to train a model on this one. Okay,
Okay, sir. Thank you, sir.
code that will work.
Okay,
Now,
sir.
let me go back and now let's start with today's lecture. So, before jumping into Hugging Face, let's discuss about the thing that we have already discussed. Now, in neural networks, you know that we can have neural networks. We can have a CNN based network. We can also perform transfer learning on that. And to perform transfer learning, we can have different kind of models. For example, LXNet, VGGNet, ResNet, MobileNet, Inception. There are a lot of them. In the exact same way for detection as well, we have couple of models that can help you detect the images, detect the objects. We also have couple of models that will help you perform image segmentation. We have models that can help you generate images. We have the model that can help you generate images of any kind. We have some algorithms. So we might also have some model that can work on text, like all these models are working on images, right? Some of the model we have not discussed in detail, but let me do the thing before anyone pointed it out. Okay, better. So in computer vision, we have different kind of tasks that a model can do. There will be different models that are doing different things. But as you can see through transfer learning, in transfer learning, we have couple of models that company has trained for classification. In the exact same way, for detection, company has also trained some model. For image to image as well, companies has trained the model. In diffusion as well, companies has trained the model. And not only in the vision task, even in NLP, where we are going to train algorithms on text, in that as well, we have different types of tasks, right? One of the tasks can be Twitter sentiment analysis, where we can uh, decide the sentiment of a tweet, or sentiment of not just a tweet, but any kind of text classification kind of a thing. This is of a positive sentiment or a negative sentiment. Here I just have two classes. If not two classes, we can also divide it into multi-class problem. Like for example, if a ticket is raised, if I want to categorize that ticket, ticket means, for example, on operations team, if you're working in an organization, like there is a team of operation where whenever I want to get any permissions or get the things done, so you need to raise a ticket, so that will be on to those things, like those operations team. And then uh, there will be some tags that need to be there, because operation team might be getting hundreds of tickets every day. So eventually, if you want to make a classifier that based on the text that user has mentioned, they can categorize the ticket. Like this is a technical requirement that has to be needed. This is about the HR. This is about different things. So that's also test kind of a classification thing. In the exact same way, we can also have models like GPT that can do the next word prediction, that can act as a question answer. In the exact same way, we can also have a named entity recognition. So there are different kind of models that we have in NLP, different kind of models that we have in computer vision. Not only that, every model will take different kind of input. Like VGJNet is trained on a different data set. AlexNet might be trained on a different data set. YOLO is trained on a different data set. Image to image unit based model, they can be trained in 1,000 ways. So that is also trained in different ways. I know if I'm talking about this particular model that we have trained, this model is taking a random noise. So to generate an image, I need to give a random noise as an input that is of 100 size. But there can be some other generator that will take 200 size image as an input, 200 size noise as an input. So every model, every AI model, be it deep learning, be it generative AI, be it computer vision, be it NLP, will take some kind of input that is of fixed size. If I've trained a generator that will take 100 size image as an input, 100 size noise as an input, it cannot take 101 size noise as an input. The input is fixed, right? So to use this generator, I need to know which kind of input the model will take, right? So eventually, just this model is not important. I also need to have some more information about this model, like the model, which kind of input this model will take. In the exact same way, if I want to make an image classifier, it's not just about I can download any image from the internet and give it to the ConvNet. I need to reshape it, resize it to the shape that my model can take as an input. So it's not just about the image that model that I need. I also need the pre-processing function, right? In the exact same way, if I want to make a Twitter sentiment analysis kind of project, it's not like you can give any tweet to the model. The tweet has to be transformed into such a way that it can be fed to the model. So to summarize, it's not just about the model, it's also about the pre-processing function, right? Which kind of input the model will take. There are also some supporting files I need to have along with model. Okay, and that is very much needed. Clear? Otherwise, it would be difficult for you, because for every model, you need to define your own pre-processing function. Okay, so that is the main problem statement. And we have different models for different tasks. Right now, I have told you a couple of models, for example, VGJNet, AlexNet, ResNet, but there are different kind of tasks that we have. So imagine if we can have one single hub, one single spot where I can get all the models that I might need. That would be great, right? I'm not only having the data set, because data set is something you can easily get, but on that data set, you need to train your own model. But imagine if you don't need to train the model, if you can get the model that if that model is already trained by someone and they have open sourced it, you can directly download that model and use it. Or you can already use a state of the art model and perform transfer learning on it. That would be great, right? So Hugging Face is one such solution for that. Okay, so if you go to this website, Hugging Face, this is how the platform will look. You need to create an account, and once your account is created, this is how your uh, dashboard looks. And here you can see I've done some of the work as well already. And now let me give you a brief about Hugging Face. Okay, what are the different kind of things we have in Hugging Face? Okay, and in between as well, if you guys have any question, uh, just let me know in the chat. Like I'll take it whenever I feel like I have some things to work on. API to models, downloaded models. Yes, you can download these models support. Okay. Now the thing is, here you can see we have different things, different like segments where you can go. First and most important segment is of models. You can go to models, and here you can see they are the models. And here you can see Quen 3 80 billion parameter model. This is a thinking model. Like if you don't know what a thinking model is, that's totally fine right now. So here you can see we have some of the model from Google. This is an embedding model. This is Vibe voice model. Probably it works on voices. Okay. OpenAI GPT OSS20B. This is also a very popular model. This is one of the first open source model. Like not the first open source model. They have open source GPT-2 as well. But this is the recent open source model by GPT, by OpenAI. And the name of the model is GPT OSS. They have released three different versions of it, three or two different versions of it, I think. First is of 20 billion, another one is a bigger model with more parameters. And you can see try this model and the friendic. If anyone can help. Yes, another one is a bigger one. So it's of 120 billion parameter. Yes. I've posted on LinkedIn about the same as well, but still I forgot. Okay, so this will give you a lot of models that are open source, that are already available on the internet. So what you can do, you can go to any model of your choice. For example, this is 1B, means this is 1 billion parameter model. This is 81, means 81B, that means 81 billion parameter model. So you can go to any model of your choice and you can use that model. But before using that model, you need to know what this model is used to do. Okay, so this one will give you a model card, which will give you a basic description of what this model is all about. And they sometimes they also provide some documentation and some sample codes that will help you easily work on this model. Okay, and here you can see there's a tokenizer.model file, there's a JSON file. And if you don't know what a tokenizer is, don't worry. We'll be having a dedicated lecture on NLP where we are going to build, trying to build a GPT. In that section, we will discuss about the whole pipeline of NLP. Right now, just leave it. Now, the thing is, you can use these models. How to use it, we'll discuss in a minute. And not only that, here you can see we also have the inference of the model. If you want to give it a try, how the model will give you as an output, you can also go to some of the model. For example, I'm not pretty sure if they will have the inference to this or not. But here you can see this is a thinking model. So here I can ask any question of my choice as well, right? What is Gen AI? I'll send the request and I'll hopefully get the response. And this is a thinking model. So this is giving you what the model is exactly thinking. Okay. These thinking models are used to make the task lists, make the planning. So for advanced tasks, thinking models are used. So here you can see for this question, this is what my model is thinking. Okay. And once your model has given a thought about it, then the model will give you the answer. So this is like rather than I can ask you a question, right? But I can ask you a question in two ways. One way is I'll say, okay, whatever comes into your mind, whenever I'm asking a question, just give me the answer. Another way is I'll ask you, okay, take a minute, think about it and then give the answer. Most of the time, if I'm giving you some time to think, you will give me a better answer most of the time. Okay, so this is about the thinking model. This is how thinking model works. So you can say this is 81 billion parameter model. I have run a sample to this as well. This sample is basically will tell you if this model is worth it or not, if this model will give you the output that you want or not. Okay, so if you want a thinking model to work on, this is the inference. If you like the inference, means this, if this is the input, this is the output you are getting. If you want these kind of answer, this is the model you can use. But directly you cannot use this model because this is 80 billion parameter model. And we'll do the calculation of these models as well, just to check how large these models are. So if I go to the files and versions, here you can see this model, which is of 80 billion parameter, has these many tensors, and all of them are of 4 GBs. And if I count them, you can easily see like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10, 20, 2, 4, 6, 8, 10, 30, 40, 50, 60, 65, or 70. So 70 is to 4. This model is of 280 GBs. 280 GBs. So if you want to run this model on your system, you cannot run it because it will, okay. So you can see 163 GB is the size of the model. Even if you want to use it, so you need at least 163 GBs of what? 143 GB of memory, space, SSD, ROM or RAM. You will need 163 GBs of ROM or RAM. It's RAM. Obviously, ROM is needed, but RAM is needed, right? And here you can see 163 GB of RAM. Are you serious? How can you get 163 GBs of RAM? And it is not 163 GB, 163 GB plus you need some additional GBs to run the system, because it's not just about running model, it's also running a lot of other things on your system. So directly you cannot run these models. So what to do in that particular case? You need higher end GPUs, GPUs which has 80 GB RAM, 100 GB RAMs, or cluster of GPUs that has 80 GB RAM. You need 4 of them to load this model. Okay, and these model cost money. So that's why to work on large language models, it's not easy for everyone without spending money to use these large language models. You can use small language models. So that's something I've discussed earlier on LinkedIn as well. The future of large language, the future of Gen A is not LLMs, large language model of this size. The future is small language models that can easily run on your system. That like it's just like when transfer learning comes into play, anyone can make the models pretty easily. But yes, SLMs, small language models, will be the future, and companies are going toward that direction as well. And there might be a couple of users who might have heard about the term Gemma. Have you guys heard about Gemma models? Nilesh has mentioned Gemma. Yes. Yes, that's great. Those who have heard about it, that's great. So Google has Gemini models, right? So they have also launched Gemma models. They have open sourced it, and they are lightweight, very lightweight, probably like 200 million parameter models that you can directly run on your own system and use it. Okay, without having any internet connectivity. Yes, they are really fast as well. Okay, so you can use any model of your choice, but that's on the system requirement that you have. Like I cannot download this model on the system, but if I have enough resources, I can. Not only that, I can go to any model, and you can see they have 2 million models. 2 million models. So whatever task you want to do, most probably you will get a model that is already trained on that task. And it's not about they have just very heavy models. They also have very small model. For example, embedding Gamma. This is just 300 million parameter model. This is something you can easily load, but this is an embedding model. Embedding models will use to generate embedding. This is 1.27 GB. You can easily load it on a RAM. And here you can see this is, here comes where exactly is the main file. This is the main model file, the tensor file. dot safe tensor. This is the main model file where we have most of the weights. Okay, the tokenizer file again. There's an NLP task, so I'm not going to dig deeper into that. And here you can also run an inference to see how your model is performing. Okay, so this is a basic intro of models, right?
Ashish, one quick question before we move forward, right? Now, previously you did mention 120 billion parameters. So this is the same thing like we spoke earlier, is it? There are multiple layers and each layer can have multiple number of neurons. And the way it is connected is what you are calling it as a parameter, right? The weights plus the biases. Yep.
Makes sense. Makes sense. Okay.
Is that so, or no? That's my question.
No, no, hi, I'm coming to that point. So
Okay.
this is a good question, and yes, now the thing is, earlier, if I go to again the perceptron one, where we have discussed about neural network. So this is how a neural network looks, and if I'm talking about this particular model, this has 211 parameters. Okay, if I'm adding more number of layers, I'll have couple of thousand parameters. I can also have couple of lakh parameters. We have also seen parameter with 500,000 parameters. We have trained those models like using transfer learning. Now, if I go here, it's not only about dense layers. It's also about convolutional layers. They have their own weights, right? And if I talk about GAN model, they also have their own things. And if I'm talking about LSTM or basically text-based model, they have their own parameters. And in transformers, they have their own parameters. So it's not only about weights and biases. There are a lot of other parameters as well that will be trained. For example, embeddings. Embedding something we'll discuss in upcoming classes. But eventually, all these parameters that you can see, like 120B, 120 billion, are the parameters that are trained. Okay. For example, in this particular model, we have trained a model of 211
Hello.
parameters. Okay. But eventually, if you are adding more and more layers into it, and more different kind of parameters into it, or uh, give more data, and obviously the model has to be complex, so it will have more parameters. Okay, so that the answer is correct. 120 billion parameters are 120 billion numbers or parameters that are trained during the training. So that is the correct answer. And yes, you are right in that particular case.
Okay, great. Thank you.
Okay.
Yep.
Now coming back to the topic, here you can see if I go to tasks, here you can use for specific tasks as well, you have models. Now, obviously, you don't need 500 billion parameter model. It's of no use for you. So you can also make it. I just want a model that is maximum 9 billion parameter because that's something that can be easily loaded on my system or easily loaded on Colab as well. I'm not going to load it on my own system. I am going to load it on Colab because Colab has GPU. I don't need to download the whole model on my system because eventually if I want to delete it, that would be difficult. And the best thing I can do is just restart Colab and the model is gone. Okay, so here you can see I can go for these parameters. I can also go for the task. What exactly do we want? Do you want a question answering kind of a thing? Do you want a text, audio to text kind of a model? Do you want an object detection model? Do you want an object classification model? So if I go for object classification, here you can see there are the models that you can use. For example, ResNet 50 is also there. So rather than using just one particular model, you can go around and see there are literally 11,000 models for object classification. And here I've added a filter like it should be less than a billion parameter. And here you can see this is 0.1B parameter model. You can also sort them based on the trending, most downloads, most likes. And here you can see this is the one, MobileNet V3. We have used V2, this is V3. This is downloaded by 126 million users. Okay, and if you want to go for like what is this VIT base? VIT base is this is basically vision transformer models. Okay, as you have seen throughout, what we are doing, we are using convolutional layers. Here we are using convolutional. Even in diffusion model as well, we are using convolutional. So this is a one-step solution. Convolutional layers are one-step solution for all the vision tasks so far. But 2 or 3 years back, the things have changed. The approach that we are using from last 10-15 years of convolutional layers, now they are being replaced with this transformer architecture. So this transformer is not used for text, it is also used for vision tasks. Transformer is an architecture that can work on text, it can work on images, it can also work on audio. So this is why transformer is a new architecture that is revolutionizing almost all the things before that. It's same like when we have deep learning, when we have neural network, this is a thing that is just one thing that can do a whole lot of tasks. So that's why we have new field neural networks. And now transformer is one such stepping stone, which has changed the way we use neural networks. Okay, it's same like okay, if you want to go faster, okay, so you have made a bike, you have made a car, you can make faster car, and you can make the fastest car. But if you want to go even faster, you can, like, eventually the thing is you should not go for a car, you should go for a plane. So this is totally different thought process that you need to take. Then you are going for, okay, I want to go for even faster. Then it's not about airplanes, it's about fighter jet or jets that are going very fast, a lot faster as compared to planes. And if you want to go even faster, it's not about jets. If you want to go to space, you need to have spacecrafts. Okay, so in the exact same way, this is also the kind of a leap that we have. Okay, so now the VIT you can see are vision transformers. They are transformers that are great at vision tasks. So you can also use these kind of models. Okay, and some of them can give you inference as well. For example, let's give it a try, and you can see this is a vision transformer patch, and here you can see what exactly this will take. So this is pre-trained on, again, ImageNet dataset for 14 million images, 21,000 classes. Everyone has 224 by 224 size image. Fine tune on image 2012 on these images, and here you can see, like, this is a sample code that will help you load this particular model and run on it. That's great, right? You can load this model directly on your system or directly on Colab and you can use it. Okay, so this is because this is an image classification based task. You can drag and drop the image. So let me drag and drop this specific image. Okay, and I just want to check what exactly it's going to classify. And this is a sample run that I'm saying. So here you can see it is classifying this having a notebook, a computer, a laptop computer, a website, an internet site, desktop computer. It is not predicting a human being. I don't know why, but this is what the model is predicting. So that is great, right? And here you can see the image that I have uploaded. What's the image that I have uploaded? Image has a size of 1344 by 768. But the moment I have uploaded it, the model will take the image of 224 by 224. How come the model predict the output of it? How come the model predict the output of it? Any guesses? Pre-processing. Once we have taken the model, I have uploaded the image is first of all pre-processed. It is converted into 224 by 224, then given to the model, then getting the predictions, then showing you the things. So here you can see it's not only about the model, it's also about how pre-processing is being done. Okay, so not only about vision transformers like image classification, you can also go for image detection. These are the models. You can go for image segmentation. These are the models. You can also go for text classification. These are the models that you can use for text classification, probably tweet as positive sentiment or negative, or go for a lot of other kind of classes. You can also go for image generation. So you can also get some, so here you can see text to image. And here comes some of the models that can directly generate image from prompt, and they are free for use. It's not like Sora where you need to pay. It's not like uh, Gemini where you can just generate two or three of them. They are state of the art models that are free to run. So you can use any model of your choice. For example, this is Stable Diffusion. I'm not going to use it, download it. I'm just going to see if the inference is possible or not. And here you can see inference is not given for this one. I want to try some other one. Let's go for Stable Diffusion. And here you can see this one is also, they are also not giving the inference option because obviously they are computationally expensive. That's also one thing. But if I go for a couple of them, you will get some of the model which will give you inference. So you can give give a text and they will generate the image as well. Okay, or eventually you can use code to load the things. So for anything that you want, for image translation, for question answering, for summarization, for text generation, for sentence similarity to find the similarity, you will get models for everything. Then what you can do, you can go for any model of your choice. You can just copy this name of the model, and through the name of the model, you can directly load this model. That's great. We have literally millions of models that I can directly use, but I need to make sure the model, if the model, it's possible to load the model on the system or not. Otherwise, it will be problematic. Okay. And this is the first part of models. You can use any model of your choice. Now, the second part is of data sets. If you want to have any data set of your choice on which you want to train a model, so you can go to data set and you can get the data set as well. For example, this is awesome ChatGPT prompts data set. If I go here, here you can see we have the fancy prompts. Okay, as the name suggests, they are awesome ChatGPT prompts. So I think they are popular prompts, or they are what I would say. This is how a prompt should be written. Imagine this is the data set. Okay, this data set might have like couple of hundred of rows, right? For example, size of is of 62 kbs. Number of rows are 203. So this has 203 well written prompts. Okay, so eventually what you can do, you can copy paste all the prompts, give it to ChatGPT and ask it to write the prompt as per your use case based on these prompts. That's great, right? I can copy paste these prompts. I'll give them to ChatGPT and I'll say, my task is to do this. Now write my prompt in this particular way. It will give you a prompt, then give the same prompt to ChatGPT and ask it to generate the things. There's also something that can be used, right? So if I go back here, you will get data set for a lot of things. Okay. And eventually you can go to the data set, download the data set from here directly as well. Okay. So here comes the concept of data sets. Okay. And you can also upload your own data set. For example, if I go to the profile, if I go to data sets, so here you can see this is the data set of some of the articles, and inside that articles, this is the data set of a Jenny based application where you need to, if you want to make a RAG based application, this is the data set that you can use. You can go to Data Studio, it will give you more detail about this data set, and this is a decent size data set. If I go to the file and versions, this is a 1.67 GB dataset. It has the embeddings of every chunk, but this is more of RAG based thing. Jenny, I think, leave it for now. But basically, the funda is you can upload your own dataset as well, as I've uploaded 2 months ago. Okay. Apart from that, you can also have spaces. Now, what is spaces? In spaces, you can get a lot of models already running on the inference. And you can also create your own space and host your own model here with minimal code. So you can deploy your models here as well. Okay. And you can go for pricing and you can check what are the price of different kind of accounts you can have and different details. This is Hugging Face. Okay. At the side, we also have a platform which is called as Kaggle. We have not discussed anything about Kaggle, right? Have we discussed anything about Kaggle? Not really. Okay. Okay. So Kaggle is also kind of the same thing. In Kaggle as well, we have data set. And here you can see we have a list of a lot of data set. The UI is a lot better than Hugging Face. Definitely it's 100 times better than Hugging Face. UI is a lot better. Here you have for everything, you have a clear cut, the data card, the data set, the codes people has published on this particular data set. So this is about data set, same as Hugging Face. And this also has the option of models. So whatever models you are getting on Hugging Face, you will also get on Kaggle. But Hugging Face is the industry standard now. Models part on Kaggle is something that they have taken inspiration, we so-called taken inspiration uh, from Hugging Face. Hugging Face is something that they have used first. Why is it free? It's free for, I don't know why it is free. It should be free for the learners, because if they started learning in any time, they have paid models for that as well. So eventually they'll generate money from inference. Okay. So this is about models, and apart from that is also have the option of competitions, where there are a lot of competition that are paid ones. You can go for the competition as well. They have their own problem statements, so that's also something you can go ahead. And here as well, you can create your own account on Kaggle. On Kaggle, if you go to datasets, these are the datasets that I have published. And in the last class we have also discussed about this dataset of image classification. Okay, every data set uh, can you can give a vote to any of the data set. A vote is like on Instagram. Okay, the more likes we have, the more upvotes we have on any data set, the better model it will get. For example, this data set has a gold medal. This has a silver one. These ones have bronze. Okay, so based on the models, based on what I would say, the upvotes, the more upvotes you have, the more models you will, medals you will have. And here you can see, I have like how many dataset published? 29 dataset published. Out of them, one has a gold medal, one has a silver medal, and another one has seven of them has a bronze medal. And I can also go for the rank. And here you can see this is the rank that I have. Like on this particular day, I have like a rank 442. This is like 890, and now my rank is 706 or something like that. And these are the medals that I have. And apart from that, on the codes, we also have medals. Okay, on the codes on the notebook that I have published, here I can also get awards, and here you can see three of them has silver medals. Okay, so the more medals you will have, it's just like your portfolio. And here you can see they will also give, they will not just give you medal, they will also give you ranks. So for example, right now I'm a dataset expert. So if you go here, you can get some detail about these ranks as well. Uh, for example, in datasets, I don't know from where to get it, but it will give you some details about your overall ranking. Okay, I think it's in view ranking. So if I go to view ranks, so here you can see, uh, if I'm talking about dataset, because I have mostly worked on datasets. So there are throughout the whole platform of Kaggle, there are 69 grandmasters. This is the maximum rank you can have. 168 masters, 1529 experts. And I'm one of the expert. And this is a universal rank on Kaggle. And my current rank is 686. Okay. And at one time I was at rank of like 120, I think. And after that I stopped it because it's a lot of work. But eventually I thought of like, let's go back on the track. Okay. So this is about you can upload your own dataset, and this is about the dataset side. Apart from that, you can also get your code ranks. Right now, like I have 3 silver medals, but based on 3 silver medals, you cannot get any rank. They will also give you like you need to have at least these many medals to get a novice, to get an expert, to get a master, to get a grandmaster, and in the exact same way, like talking about dataset, that's the current rank. Okay, and the more awards you will have, the better ranking you will have. Okay, and not only on the dataset part, on the code rank as well. For example, I can go to my profile, I can go to codes, and these are the codes that I have published. I need to wait for it. Okay, and here you can see this one has 72 awards. This has got a silver medal, another silver. I don't know why this one has 76 awards but no medal. I don't know, but okay, leave it there. And apart from that, there is another one, just 21 votes has a medal, but 76 one awards don't have a medal. But that's fine. Okay, I'm not crying for that. So this is how it works. Clear? So make sure you need to have an account on Kaggle as well. Make sure to have, uh, I'm not saying this is a very professional picture. Make sure to have a decent account with a decent profile picture, with have some basic bio, and also whatever possible, publish it here. Here you can see I have published my models here as well. This is gender classifier model that I have shown you earlier in the last class. This is Tiny Story LLM. This is also the model that I published here. And in this particular data set, this is a model of 340 MBs. And there are 5 of the models. Each one has probably like 60, 70 MB. We are going to train this model as well, Tiny Story LLM. This is probably the project of tomorrow or day after tomorrow. I don't right now, but we'll have this project as well. So on Kaggle, on Hugging Face, you need to have an account. This is very much important. Okay, if you have an account on it, then the rest of the thing would be easier. Okay, for example, whatever project you have made, you can directly publish it here as we have seen it. So for example, this is gender classification 200k images. If you don't want to work on these data set, there's a smaller version of it. I don't know why I have made it, probably for the user who don't want to uh, train it on this huge data set. I've also made a 20k version of it. Now, if I go to, for example, this data set, you can go to codes and create your own notebook here. Code, create a notebook. You can create your own notebook and here write the whole code by yourself to train a model. Once your model is trained, add a good bio and add whatever detail you want to add and publish it here. So this is the open Kaggle notebook. You can copy this link, add it in your resume. Like if you want to add this project in your resume, just directly add this link because the user can go to your project and see how well you have documented everything. Okay, this is not a very good documented project, but this is just want to tell you like you can use these things. Okay, so you need to have an account on Hugging Face, you need to have an account on Kaggle. They are two very important things. Now let's get back to this notebook. And here you will see how easy it is to use models. Okay, now, sir, can we have copyright on our published data set? Okay, uh, you can have it if it is something proprietary to you, like you have made it by yourself. But if it's just an open source data set on which you have done some updates and publishing it again, so then you cannot have it. Okay, so and for that purpose, we have what I would say licenses. Okay, so you can go for that as well. How we can create our own data set and upload it on Kaggle? Please give example. Okay, I'll talk about this question at the end. Make sure Shruti कि आप मुझे एक बार remind करा देना last में. Okay, so here you can see what I'm doing. I'm importing first of all some important libraries, and here you can see on Hugging Face there are different model for sentiment analysis, for text summarization, for question answering, for named entity recognition, text generation, image classification, image detection. We have different models for different things. Now what I'll do, I'm going to load those models, run it on Colab, and I'll see how each model will take as an input and how the whole process will go. Okay. And for that purpose, first of all, I'm importing some important libraries. I'm also importing this transformers library. This transformers is a library from Hugging Face, which will help you download any dataset, any model specifically from Hugging Face. Transformer is a library that will help you download any model from Hugging Face. In the exact same way, we also have a library called as datasets. Datasets, as the name suggests, will help you download any dataset from Hugging Face. Okay, so as we are installing it, and after that, I want to run a sentiment analysis project. Okay, so what I have done, if you look closely, from transformers, I have imported a pipeline. What is pipeline? Pipeline is basically everything about a model. Okay, I'll discuss about pipeline in detail in a minute. But here you can see I have imported a pipeline of sentiment analysis. So eventually my task is I want to make a sentiment analysis project. Okay, I don't want to train an algorithm. I'm going to load a pre-trained model through pipeline. That the pipeline is sentiment analysis, because eventually what I want to do, I want to make a sentiment analysis project. That's it. I have not defined which model I want to use. I have not defined anything. I just want that I want to perform sentiment analysis. So what this transformers library will do, it will load a default model. There are different pipeline. One pipeline is for sentence classification. Another one would be for text summarization, question answering and everything. So there is a pipeline for everything. Okay. And inside that pipeline, there are different models you can use. You can not pass it anything. It will download the default model. Okay. And eventually what I'm doing here I'm passing. I love using Hugging Face pipeline. That's so easy to use. And here, this sentiment analyzer function I'm using, passing the text inside that, getting the result and printing the result. So if I'm executing it for the first time, if you look closely, what it is saying? It's saying no model supplied. We have not supplied any model. So it is using a default model. Which model it is using? Distillbird base uncased English. This is the model that it is using. I can also go for Hugging Face, pass this model, go to the first link. So this is the default model that Hugging Face is using for sentence classification. If you want any other model, you can use that as well. But this is the model that we are using. And eventually, if I go back, this is the default model that it is downloading from this particular link. And till here, it is downloading the model. The model is of, here you can see it is downloading the model. It's of 268 MB. But if I'm executing it, the model is downloaded. And here you can see this is the output we are getting. Label positive, score 99%. So it's 99% chances, like it's 99% confident that it's a positive label. What if I'm executing it again? Will it load the same model? If I'm executing the same code again, is it going to download the same model? Yes, because this is the default. But this will not download it again. It's already downloaded. So you will not see the progress bar of downloading it. It's already downloaded, right? And it's using the default model. So this is what we have got as an answer. And this seems a list. And we can also check the data type of it. For example, I can write the type. And here you can see it's a list. So inside a list, if it is a list, inside that we have a dictionary. So I'll go inside the list, eventually have the dictionary. And from the dictionary, if I want to just print the label, I'm printing the key, and the answer is score. I can execute it, and here's the output. That's pretty simple, right? And this is taking the default model. Okay, now what we can do, we can also check the what I would say documentation of this. If I hover over it, here you can see this will take couple of things as an input. Okay, so here you can see one of the parameter is task, another parameter is pre-train config, tokenizer, and we might also have the option to give my own model that I wanted. So what I'm going to do now, I'm going to the description. Okay, so documentation basically. So I'm asking Gemini. You can also go to ChatGPT and do the things. That's also totally fine. So I'm going to, okay, go to the documentation and ask and give me different parameters I can pass in this pipeline. Okay, let me zoom a little bit in. So this will basically go to the documentation of pipeline. You can also go to direct documentation. You can go for like transformers, uh, library, pipeline documentation, and there's the pipeline. Here it will tell you what are the different kind of pipelines you can use. And inside the pipeline, you can also pass a model of your choice. So this is the model that you can pass. If you directly passing a model, you don't need to define a pipeline because a model is designed to do one specific thing. Okay, so if you are directly importing a model, you don't need to go for a pipeline kind of a thing. So here I can also pass this model. So let's give it a try if this model will work or not. Okay, let's not go there. So the sentiment analysis and I'm passing the model is this one. Just want to give it a try if this model will be downloading or not. And here you can see now it is downloading this model, which is of 1.43 GBs. This is a big model. I can go to this RAM stats and here you can see it is using all my RAM because I don't have GPU resources. I've exhausted it. But here, this is how it goes. And it's not mandatory that this will give you the same kind of output, but most probably it will give you the same output because it is sentiment analysis. Okay, so it will download it. And again, if I'm executing it again, once it is downloaded, it will not download it again. So I've defined a pipeline, and for the pipeline, I have also imported a model. Without the pipeline, without this task as well, I can import the model because model is already designed to do a specific task. Okay, so we need to wait for it to load, but eventually there will be the same problem. The RAM will exhaust. So eventually, this is the main task that I need to do. Okay, so here I have made a pipeline and I have also discussed how you can load any model of your choice. Once your model is loaded, here you can see once it is downloaded, then this RAM will shoot up because it is going to load 2 GB model on the RAM. So already there are some computational resources being used. So it will shoot around 6 to 7 GBs as far as I'm expecting. Okay, so it is downloading it. And again, coming to the same point, if we are downloading half a GB, 1.5 GB model, it's not using your internet resources. It's not taking 1.5 GB of your internet usage. The model is downloaded from Hugging Face and downloading in Colab. So it's not at all taking your resources. And here you can see this is the output we are getting if I'm executing it again. Okay, this is using the default model. But if I'm going for the same pipeline, that model is also loaded. Okay, so now this is giving you the answer based on Facebook Roberta large MNLI model. Okay, so this is sentiment analysis kind of a project. How you can take any model of download it from the internet and do the sentence classification. That's an easy part. In the exact same way, the second task is of text summarization. So I'll use text summarization pipeline. I will give the text. And because this is text summarization, I need to pass couple of parameters. What is the text that has to be summarized? What is the maximum length? What is the minimum length? And do sample is something I need to check the documentation, what this do sample is doing. And eventually I'll get the summary. So this will basically define, do you want a 50-word summary or 10-word summary? Or in that particular range. So between 10 to 50 size, I want to get the summary. So here I've added a long text and this summarizer pipeline is downloading a model. Now, which model it is downloading? Any guesses? I have not passed any model. How do we know these parameters? You need to go to the documentation of summarizer. Okay, so for example, this is for text classification. They mention this is the pipeline. And in the exact same way, you can go for different pipeline. This is sentiment analysis pipeline. In the exact same way, uh, you can go to the documentation, or let's go back and reach from there only directly. So documentation of summarization. So it will hopefully open the summarization pipeline and give you what are the different things the summarization will take. So it will take this, it will ask the summarizer, and then through summarizer this will download the model. And once the model is downloaded, you can pass it. You can get a lot of resources on the internet. Okay, so it's not like one solution for all the problems. Even ChatGPT will give you the sample code. Okay, but best way you can do is ask ChatGPT to give you different parameters it can take, or either just hover over summarization. Summarizer, it will hopefully give you the documentation for the same. This is the sample code for summarizer. You can pass the model, you can pass the tokenizer, and this is the link from which you can get the main classes. Okay, and eventually here you can see this is the summary that this model has generated. Summary, and it is in a list format, so I can go for summary of 0, and inside that I have summary text which is in the dictionary, so I'm printing the key. Do we have anything else? Nothing. So if I'm executing it again, the model is already downloaded, and it is downloading this model distilled bird. It is using CPU, and it will hopefully give you the summary of it. And if I'm seeing the RAM, it is using 7.4 GB of it, because now this has not only the sentiment analyzer model, it's also having the summarizer model. Okay, so this is how you can use any model to do text summarization. That's great, right? So now to find the sentiment, do sentiment analysis, you don't even need to train a model. You can use a pre-trained model, give your data to the pre-trained model, get the summarization, get the classification done. That's it. Okay. And this is about question answering. Question answering basically means this is the context. Based on the context, I am passing the question. And hopefully it will give you the answer. So basically inside this context, I'm basically talking about something, and then I'm asking a question. It's same like you have a chapter, you have read the chapter, and then uh, we are asking a question if the answer can be given or not. So pipeline is question answering, execute it. This again going to download a model, and this model is 261 MB. So it will be downloaded, and once the model is downloaded, this is the context, this is the question, it is going to give you the answer. Okay, so the answer of it is starting at 61st. Probably this is the index from where exactly it is starting. This is the end. New York City and Paris is the answer. Okay, so this is question answering. For question answering as well, you can go to Hugging Face, see what are the models that we have in question answering, load the model there, and that's it. Okay, so here as well, if I'm executing it again, that's totally fine. The model is already downloaded, so it is not needed to download it again. Right now, it's not downloading it, it is just fetching the file. It's just processing. In the processing, it is showing you the progress bar. Then we have named entity recognition. What is named entity recognition? Any guesses? Like, it is downloading the model, and now very soon it's gonna exhaust the RAM. What is NER? Don't know? Okay, that's totally fine. So basically, whenever I'm talking about Hugging Face, what is Hugging Face? Is it a company or a person or an object or what? New York, what is that? It's a city or what? Right? What is Paris? So this is named entity recognition. It will basically tell you what each object is, what each word is. Is it a noun? Is it a helping verb? Is it an object? Is it a person? Is it an organization? What exactly is this? Okay, so this will help you get important information about each word. So if I'm executing it, here you can see the model is downloaded, and executing it again, here you can see something. This is giving you a list again. Entity group org. So we have an organization, Hugging Face. Hugging Face is an organization. LOC, probably a location. New York City is a location. LOC, we have another location, Paris. So this will entity relationship of database is not that. Okay. So NER, is it a classifier? Yes, it's kind of a classifier. Okay. But the thing is, if I'm writing I like Apple, but Samsung is better. Okay. What will happen in this particular case? Okay. So I like Apple, but Samsung is better. It's not giving any output. Why? Why is it not giving any output? Okay. It should give an output. Yes. So here you can see Apple is an organization located in New York City, Paris, but I like oranges more. Okay. So here you can see New York City is a location again. Here comes another location. This is MISC. I don't know the full form of MISC, but again, it is of word orange. So this is named entity recognition. Miscellaneous. Okay. Thank you so much. So, and here you can see it's also downloading a default model. If you want to use any specific model of your choice, just pass the model. Okay. Now, this is for text generation. This is a good one. Now, if I'm executing this one, and the assignment is related to this one as well, assignment will be related to the text generation. So stay tuned for that. So make sure that you like are giving 100% attention to this text generation. Can we use this method for sentiment analysis using Hugging Face model industrial project as well, like for a client? Yes, for sure. Why not? Yes, 200%. We can use these projects. You can use these models. And what companies are doing right now, for example, there is a company which has used Llama model, open source model, fine tune it on their own, not their own, on publicly available data set. And then they said, now we have made an LLM. Okay. And they have made that LLM Aryabhat. Okay. Can you name that company? Anyone? The company has claimed that they have made their own LLM that is very great at maths, and they have named it Aryabhat. No idea? Okay. It's fine if even if you don't have an idea. Search on the internet, you will get the name. Okay. There's a famous company. Okay. How these tech news are you knowing, sir? I've seen it on LinkedIn. It's just about yes, Nilesh guessed it right. SPW. Okay. Uh, it's not a very great thing, but yes, they have done it, and even a lot better models are already available. So it's just like a publicity stunt the company usually do. Take up an open source model, take an open source data set just to make the hype, fine tune it model. Even if it is not working, they might say, okay, now we have our own LLM. It's not a big deal to have an LLM, their own LLM right now. Get back to the text generation part. So right now, can you tell me which model is now updated? Okay, Tejinder, like this is also an important thing. Make sure to add this question at the end, as ask this question at the end as well. So I'll discuss about how you can create your own data set as well as this question. So make sure at the end we'll have a discussion on this. Okay, I have enough battery, I don't need to charge it. So the thing is, let's get back to this one. So we are using here GPT-2. So there were some good old days that then OpenAI was open sourcing their models as well, that you can directly download and use it. Now it's close AI, not open AI anymore. They have all these closed source model for everything. You need to uh, have an API key, talk to their servers, and then you will get the answer. So nothing is uh, so data security is a myth nowadays. So now what we are doing, I'm downloading GPT-2. Yes, good old days when there were mod. And here you can see GPT-2 model is just 500 MBs, just half a GB. They have trained their model GPT-2 just half a GB. This is the half a GB model. And now GPT-5 is more than a trillion. Yes, more than 1 TB. More than couple, it's couple of TBs. Literally couple of TBs. Okay. So this is a huge jump they have made in just last 4 to 5 years. Okay. So now what I have done, this is a text generation model. So obviously I need to give some text first, right? So I've added a quick brown fox jumps over a little lazy. So hopefully it should give the answer dog. And here comes, like, we need to wait for it to load. There are high chances the RAM will crash, and here you can see it's decently managing it. And right now, because I'm using CPU resources, so it's taking a lot of time. If I'm using GPU, it will not take that much of time, but I don't have GPU right now because I've exhausted all the free quota of Colab. So you need to bear with me. So if you look closely, the quick brown fox jumps over the lazy and the lazy wolf, slinging his arm around the wolf, and then it is taking you to the next line. So if you go to this, so we have generated text. So I can also go for something like this of zero of generated text key. So I'll get the value of it. And let's see if we have any another key or not. And if I'm executing it, now this time it will return you the actual output. Okay, so here you can also mention what is the maximum length you want to have. So maximum length is defined 30. I don't know why it is generating more than 30 words, but you can also define the maximum length, and you can also define your own text generation model. As on Hugging Face, we can have our own models as well. For example, you can go to Hugging Face and ask it to go for text generation. So rather than using GPT-2, you can use any of the big models, not these big models, just shrink it down. You can use Vault Gemma, you can use Gemma 3270B. This is also a very decent model. You must give it a try, but there are high chances you cannot directly use it. You need to go here, you need to like go for terms and condition. You have granted the access for this model. If you are opening this link, you might not get this. Okay, so you need to basically fill a form that you want to use this model, and they will approve it, and then you can utilize this model. Okay, so there are some models that you can directly don't use it, you can not directly use it. So here you can see this is what we are getting. This is for text generation. You can use any model of by yourself as well. So this is for text generation. Now comes image classification. Now for image classification, what we are doing, I'm importing the same pipeline of image classification. It will use a default model of that is just 1/3 of a GB. We are using VIT. This is the default model. This is Vision Transformer by Google. And how come this image? This is a link of this image. So what we are doing here, I have written the code where it will go to this particular image, download the image, and after downloading, passing it to the image classifier pipeline that I have imported. I'm getting the classification result. I'm printing the output as well as plotting the image. So here you can see in the output, I am getting labels. First label is Egyptian cat. This is the output. Second label is it's a teddy or a tabby or a tabby cat. This is the score. Third is a tiger cat. This is the third. Then here's the fourth one, fifth one, and it is basically giving you the top 5 result. If you want top 10, you can mention it here as well. Top key, I think, is the parameter. You can go for the image classifier and get that as well. So here you can see it will return you a classifier. And what are the parameters that you can pass? So none softmax sigmoid function you need to get. So batch size. Okay, so basically this is the image classifier. Okay, and this is the list of dictionaries. So this is first dictionary, second dictionary. You can go for a for loop then. You can easily go for a for loop that will print all the classes that you want. For example, you can go for class in, okay, classes and the classification go for 0 so that, okay, so yes, directly we can go ahead. Once it is done, if I'm printing the classes, so it will print all the classes one by one, and then you can print their classes as well as there. For example, this, there will be a label, and we can go for the classes as well as their score. And that's what we have. Egyptian cat, this much score. This one, this much score. And if you want just the top two of them, just write top two. Through indexing, we are getting top two of them. Like there are 93% chances it's an Egyptian cat. That's correct. Okay. And this is object detection. You can give any image of your choice. In the exact same way, we have object detection. For object detection, the pipeline is object detection. I'm downloading the model, and this time I'm having some extra code. Okay, what is this extra code? Okay, and what is this image draw function? Okay, so first of all, we have print the detection result. Let's run this code and then we will see what exactly is happening. Okay, first of all, this is the image that we have. If I open it, this is the image, same image. Because this is object detection, so it will basically hopefully object, this is a cat, this is a cat, this is a remote, another remote. This is what we are expecting, right? But eventually this is an image. So if you want to detect at this particular area, we have a cat, at this particular area, we have a cat, at this area, we have a cat, at this area, we have a cat. Eventually, I will need boundary boxes that has to be drawn. And to draw a boundary boxes, okay, how many points I need to have to draw a box? I need 4 points. That makes sense. What are the minimum number of points that I need to draw a box? 2. And though these two are top left and bottom right. If I have these 2 points, I can do the drawing, right? At least 4 points are needed, means 4 points are needed, but at least 2 will also work. Okay, so, and to make a point, obviously I need to have their x-axis and y-axis, and for the second point I need to have x2, y2, then only we can make it a drawing, right? So inside this detection, like here you can see that it's detected it, but let me run this code again. Okay, it has some warnings. Okay, let's avoid it. If you look closely, here you can see we have a score. We have a label remote, means it has found something, but it is giving you x min, y min, x max, y max. What are these 4 things? X min, y min, x max, y max. These are those 2 coordinates, top left and bottom right. Okay, so basically, whenever you want to, okay, imagine if I want to draw this particular rectangle, I just need 2 points. This is the top left point, this is the bottom right point. Even if I have 2 points, I can draw a rectangle. What this model has given me, this model has given me x min, y min. This particular point, this one is giving you x max, y max. This particular point. So if I have 2 points, I can draw a rectangle. So this whole thing from this till this whole thing is one object detected and mentioning where exactly do we have that object. Through these coordinates, we will draw these objects. How we are drawing it? Through the for loop that I have added on the top that we'll discuss. Then comes the second object. It's another remote at this particular points, x min, y min, x max, y max, to another point, 2 more points. Then we have another object, a couch. Then we have another object, a cat. And then I finally have one more cat. So if I go back to the original image, so here it has detected 5 objects. Okay, right now, okay, you can see there are just 4 objects. Why I'm getting 5 objects? This seems like 4 objects, right? But if you look closely, we don't have 4 objects, we have 5 objects. If you look closely, here comes the red line. The big box is also there, right? So there is a big box, inside that I have 4 boxes. So in total, I have 5 images. Overlapping them, that's totally fine. Because otherwise, if overlapping is not disabled, so in that particular case, we cannot say it. It seems like the red, like the outer box seems like the border, but it's not the border. Okay, they have objected that this whole thing is a couch. On the couch, we have a remote. On the couch, we have one cat, another cat, and so on. Okay, so this is how object detection can be done. Okay, and now if you go on top, what we are doing, this one will give you draw. What is draw? Detection result. What is this detection result? This whole list of JSON. First object x min, y min, x max, y max. Okay, then this for loop will take the boxes, will take the x min, y min, x max, y max. Using draw dot rectangle function, we are drawing a rectangle. The color would be red. Width is 3. If I'm adding width to, for example, 7, I'll have more width. I have like thicker borders. Okay, and here you can see, can you now see clearly all these borders, all these detections? And rather than going for red, can I go for a blue? Hopefully we can. We can go for blue. And these are the objects that are detected. Okay, in the more advanced version, can it detect moving objects as well? Yes. What we can do, okay, moving object, let's think of it as a video. Video is made up of images, right? All of you guys are clear about that concept, right? A video is made up of images, right? All of you, right? So if I'm talking about a 50 pixel, 24 FPS video, what is 24 FPS? You might have heard about 24 FPS, 30 FPS, 60 FPS, 120 FPS, 240 FPS. They are frames per second. How many frames are there in a video of 1 second? More frames, smoother the transition. Okay, what is the FPS of human eyes? What is the FPS of human eye? Is that 60? No, it's around 24. 24, I'm talking about FPS, I'm not talking about image quality. So it's how many frames we can process in a second. It's 24 FPS. And imagine if we have a helicopter, it's revolving, the blades are revolving exactly at 24 oscillations per second. We might seem it like the blades are still. This is one of the same reason the blades are static, right? So this is 24 FPS. So what we can do, we can load in a video. And to load a video, we are loading each and every frame, right? Can I do this thing? Load first frame, perform object detection on that, show you the boundary boxes. Then take another image, show the boundary boxes. Keep on doing it on real-time basis. That's it. The same object detection model running, working on running frames is the object detection on videos. You can use the same model on running images as well. It will take a lot of time, for sure it will take a lot of time. That's why object detection models are computationally really expensive, because it is not only about time taking. Imagine if your model is faster, but it can just parse 12 frames per second. What will happen? My video is 24 FPS. The model can do the detection, but only at 12 frames per second. Then what will happen? Will it miss the data? It will lag. It will lag for sure. Okay, because it can only pass 12 frames. So it will take 12 frames in a second. So every frame is visible. It seems like if I watched a 60 FPS video or 120 FPS video, the smooth transitions are very smooth between the frames. But on 22 FPS, 24 FPS specifically, it's not that much. So it will not skip the frames. It will take the frame, but video will lag. It seems like playing a video on 0.5x. This is how it will look. So you can also run that thing. Let's go back to the topic. So this is image detection. In the exact same way, I'm performing image segmentation. Now, what is image segmentation? Remember, this is exactly how image segmentation looks. And now we are doing kind of the same thing. So we are downloading a model, a very simple, not very much hidden model. So this is the model from Facebook. And this is the default model. As I've told you, you can use any model of your choice. This is the default pipeline I'm using, default model I'm using. So it is downloading it. And once downloaded, it will print the results, segmentation result. And along with that, this for loop will draw these segments. Like this for loop was drawing these rectangles, right? This for loop will draw the segments. Okay. And if I go there, here you can see it has drawn 1, 2, 3, 4, 5 segments. Okay. And if you look closely, what do we have here? So you can see the first, it has encountered a cat, and here you can see this is the image that we are getting as an output. Okay, this is the mask of the first label cat. This is the mask. So the image is nothing but this mask is nothing but a whole image of 640 by 480 size. Here comes another label, and this is a remote. Here comes the third label, third image of a remote. Here comes the fourth image of a mask. Here comes the fifth image of a mask of a cat again. Sorry, not mask, it was cat. So now if I go back, I'll take each and every image inside mask. This one is an image. So if you go here, here you can see I'm printing the mask. Mask is nothing but the image. So I'm showing this image. And I'm also printing the label of that so that you can see what exactly this image is. So from this image given the input, it will return you 5 different images as an output, 5 different masks as an output. So this will help you do image segmentation. So it's not only at this particular we have a cat, it's on pixel by pixel telling you this is the exact region where we have cat. Okay, PAL full form in the context is pillow. It's named as pillow. I don't know why it named as pillow. It seemed like I don't know why we call it hugging face. Okay, obviously the icon looks like a hugging face, but I don't know why some company named their what I would say name itself hugging face. Okay, if you guys have any good answer, sounds cool. I don't think so, but okay, let's think of it in this way. What does AI Swiss Army knife means? Swiss Army knife means, okay, that's just a fancy name that we have added. It's like Swiss Army knife is something like there's one knife that can do all the things for you. You can do cutting, you can do chopping, you can kill your enemy, you can do anything. So it's like one shot solution. Hugging face is just like the Swiss Army knife. Okay, one shot solution for all your tasks. NLP task or your vision task or your transformer task. Yes, it's like Sanjeevni. Right then, man. Okay. Raman hai ye. Okay. Scientists like naming differently. Yes, that might be the reason. Okay. So then comes translation. So for translation, we have another translation. Here I'm loading this model. It's not like if I'm not downloading this model, it will do this. But here you can see here, this model is designed to do for English to French translation. So if I'm executing it, it will download the model and this text will be converted into French version of it. Okay, so for different translations, you will need different models. So you can go to the pipeline and see which kind of translation you want. Okay, imagine you have a whole book that you want to translate into your native language, probably English to Hindi. So what you can do, take the whole book in text format, go for a for loop, load any model of your choice, take each and every paragraph one by one and give it to the model and get the Hindi text converted. That's it. Without using any paid translator, you can directly translate it using your codes. That's great. And you can also use some state of the art model. You don't need to use a 300 MB model because you can load a heavy model for that as well. Because Colab provide you 12 GB of RAM. So you can load like 7 to 8 to 9 GB of model. That's totally fine. Okay. So you can do that. Now I'm about to exhaust the RAM, but okay, let's see how much more it can take. Okay. And then comes a zero shot classification. Zero shot classification means, let's suppose this is the text. What should be the tags of this text? That is zero shot classification. I've not given any data. It will automatically classify like this is from which all specific tags. Okay. And you can add any text here. You can add any class here as well. Okay. It's not like there are some predetermined class that it can take. You can add any class here as well. It will do the exact same thing. Okay. So if I'm executing it, it will download this Facebook Bert Large MNLI. Once it is downloaded, here you can see this is a great movie about the future. This is the sequence. The label is entertainment, technology, business, politics. Score is this, this, and this. Can you tell me why I'm getting 4 scores? Why I'm getting 4 scores? Probability. If you look closely, 75.75 is there, 0.24 is there, then they are very smaller values. So all of them will add up to 1. That means kind of a softmax activation function. It is a probability distribution that the maximum chances of entertainment. Entertainment is maximum, then comes technology. So basically, this is a great movie about the future of AI. It's more entertainment because we are talking about the movie, but let's about technology as well because this is on the future of AI. That's great, right? So this will help you do the tagging. Zero shot learning. Why zero shot learning? Because I've not trained anything on it. I'm loading a pre-trained model. I'm giving the sample text. I'm giving sample classes and it will automatically classify it. And from here, I can sort them because it is sorting in this particular manner. I can print just the top 2 of them, top 3 of them, or top 1 of them. This will also work. Okay. And then comes image captioning. What is image captioning? Any guesses? What is image captioning? Adding captions to an image. Yes, that does make sense. It's like describing an image. Adding captions to an image, describing an image. That's it. Okay. So image to text is the pipeline because image to text will basically describe the image. Take this particular model. You can use any model of your choice. Take this image, download it, give it to the image captioner. It will generate the caption and just print the captions. That's it. All the pre-processing, everything is done in the pipeline. You don't need to do anything. Just run the code. It will generate the captions. So for example, that's the caption. 2 cats sleeping on a couch. This is the output that we are getting given this specific image. So right now, this is why AI is very easy nowadays. If you just want to use the models, because there are literally millions of models available out there. Whatever you want to do, most probably you'll get the model already available on the internet. You can just fine tune it as per some of your own use case, but you can directly use it. And Hugging Face has made it very simple. Just directly load a pipeline. If you don't want to load a pipeline, just mention the model of your choice. It will load the model as well. Okay. And here you can see this is again a 990 MB model. I don't want to run this code. This will do exactly the same thing as I have done, but I don't want to do it right now because I know my RAM is about to exhaust. I don't want to turn this off, turn this kernel off. Okay. So right now, as you can see, in just last half an hour of doing the code, these are all the different kind of things that we have done. AI Swiss knife, RAM exhausting model. So sentiment analysis, there is a pipeline. Text summarization, there is a pipeline. For all these different kind of tasks, be it text-based tasks, be it image-based tasks, we have pre-trained models. Even for text generation, we have pre-trained models that we can directly load. Okay. Uh, Sampoon sir might take some of your classes where they will see how you can load models that are more than your RAM. For example, the RAM of your system is 12 GB. What if you want to load a 24 GB RAM model? Can you do it? There are ways we can do it as well. Okay, we call it quantization. Okay, or there is a library named as Unsloth. I don't know if I've used it or not. There is an open source model. Like the website states it all. Train your own custom model in 24 hours, in 24 hours rather than 30 days. It will take 90% less memory usage, 30% faster. And there is a tagline that I've seen that was very promising. Mm, I I don't know why I'm not finding it when I really want to see that. But they mention like you can load like 2x, 3x, 4x size of the model in like 1/4 size of the RAM. Okay, so this is again a library through which you can load very heavy models on a system as well. Quantized model or yes, model quantization is a technique that will help you do so. But this is about the pipeline. This is about the whole pipeline. Okay, so you can download any pipeline of your choice. You can load any model of your choice. If it is open source, if it is directly available, it will be provided directly to you. Otherwise, you need to first of all, otherwise it will ask you. For example, if I am trying to load this Gemma model, okay, Gemma is something that can be loaded, but otherwise, if you try to load a model, they will say, okay, this model cannot be directly downloaded. Make sure to go for this particular document, accept terms and condition, log in, and then the model will be downloaded. They'll also give you some sample code that you need to add here so that it's just like an API key access connectivity that you need to do, but it will do the rest of the things. Okay, so can only run LM Studio. Gemini and Gemma both are different. Yes, Gemini is the model that they have not open sourced. They are very high end model that we are using. Gemma is based on the same technology but a very lightweight model that they have open sourced. Both of them are from Google. Okay, to generate a specific programming language as well using this model. Generate. Okay, is there a way to generate a specific programming language as well using this model? Uh, you can give it a try. Yes. Okay. Because I don't think so. Like before, like more easier than Python is English. Okay. So then you can just direct go for prompting and prompt based apps. That is a lot of tools that already doing it. So just but you can give it a try. You need to go for a lot of brainstorming kind of a session, like what exactly need to be there, how to do it. But okay, you can give it a try. Okay. What is the submission task of today? Submission task of today is pretty easy. Okay, your task is a bit of prompt engineering kind of a thing. Okay, where you need to use GPT-2 model. That's the conclusion. Okay, sorry, that was not the task. Sorry. Okay, you need to go to this link. If you go to this link, it will reach you here. Stability AI. They have made a lot of models. Okay, they are the ones which has made stable diffusion models. Okay, so you can go to their collections. So here you can see they have stable diffusion 3.5 medium, 3.5 large, 2.1, 3.5 large. There are a couple of them that can be easily run load on your system. There are a couple of them that will exhaust all the RAMs, and here you can see there are list of models. Your task is to load any of the image generator models. For example, if I'm going for the most download ones, so you can see this is Excel base 10. This is a text to image generator. Most of them are text to image generator. They are image to video, text to video as well. You need to load any of the text to image generator model from Stability AI, be it this one, be it this one, or if you want to give it a try, even if you are going for this specific model, that will also work. Your task is to load this specific model, okay, or any of the model, load it, generate images out of it, of anything of your choice, display and generated image, and write a brief discussion about it. And to write a brief discussion about it, you can read another model that is used for text captioning, image captioning. Does this make sense? So basically, you need to use a diffusion model to generate the image and use a text captioning model or image captioning model to generate the caption from the generated image that is just generated. Okay, so for that purpose, what you might need to do, just understand the process. Okay, first thing, so it's text to image, image to text. Yes, this is what Kujagra has understood. First of all, go for Stability AI. Load the model that I'm going to share the link of this model as well. But apart from that, you can use any model of your choice. Load the model, give it a prompt. Based on the prompt, it will generate an image. Download the image on local on the Colab directly. That also works. Then load the image, give it to image captioner that will write a basic description about the image. That is it. That is your task for today. Okay, I know this is not a very difficult task, but I can give you difficult tasks. But I know one day would be more than, like, even a week is not more than enough. Okay, so this notebook is something I'm adding within 5 minutes in the reference link, uh, in the reference of the web page. Now I have asked you guys for a couple of questions that you guys already have. Uh, at least one normal assignment you can give. Yes, I have given it into one prompt. That's on you. You don't need to merge it into one prompt. There's one prompt that will generate the image, and then the image passed to image captioner that will generate the basic description of it. So it's like closing the loop. Okay, so Apurus has mentioned the question. The first question is, how can we generate our own data set? Okay, so there are multiple ways you can generate your own data set, and for that purpose, let me go back to this. You can take reference from this one. It's not like they are the best data set that I have because I have made it, but if you look closely, there is a technique called as web scraping through which you can scrape the data from the websites, from the internet, and then you can publish it. Okay, so there's one way of doing it. Another way is, for example, if I'm talking about gender classification data set, do you think inside this data set I have collected all the images from the internet? The answer is no. Here I've clearly mentioned that this is the data set that I have pre-processed from the select phase data set that I've already shown you. So from the select phase data set, yes. So from the data sets, if I go to celebrity faces, and here you can say Animal Crossing New Horizon catalog, this has 54,000 upvotes. That's a pretty huge thing. Okay, but let's go back to this data set. So you can see here we have images, but along with that, we also have attributes. Okay, so this is attractive or not, bags under the eye or not, bald or not, uh, big lips or not, black hair or not. In the exact same way, it also have some feature like male or a female. So based on this particular data set, I have pre-processed this data set, generate a new version of it just for gender classification. And I pre-processed it in such a way that it would be very easy for you to train a model. And then I've created a new version of it. That's it. And here you can see, because of that, I've got a bronze medal. Right? It's not like you need to have your own data set. You can make life easier for people as well. Okay, one more example. For example, this is the data set, Doodle data set. Okay, this is the data set where do I have given the reference from the original data set? So I have mentioned it here, but I have not added all the details. So if I go for quick draw, have you guys visited this website earlier? Quick draw, anyone? No, that's fine. This is a website from Google. So this is a gaming website. Okay, so you need to draw a rock, draw a rake. What is a rake? Sorry, I'm not very great at English. Okay, I need to draw. Okay, this rake. So now I need to draw it. So
I see line or hockey stick. I know, it's rake.
okay, so I have made this drawing. Now I need to draw socks. Okay, so basically what it is doing, it is giving you a timer of seconds and you need to draw it. Whatever you are drawing, it will recognize. If you are recognized, it will give you points and you can move ahead to the next one. Okay, so now I need to animal migration. Now, how will I like probably?
I know, it's animal migration.
Okay, now sometimes even if you are not driving the like drawing the things correctly, it will recognize it. Why I'm showing you this game? Because using this quick draw, they have world's largest doodle data set. Whatever drawing are made so far, they have documented everything. They have saved everything. This has 50 million drawings across like 350 classes, I think, if I'm not wrong. Okay. Okay, we'll discuss about that. This has over 50 million drawings across 15 million players. So this is a pretty huge data set. They have open sourced it as well so that anyone can use it. And here comes the code, how to use it. This is a complex task, right? For anyone to use it. So what I have done, I have done it by myself, but not by loading all the 50 million images. I have just loaded 1 million images. Okay, so this dataset consists of 1 million images across 340 classes. So you can do the division and get to know like how many images are there per class. So here you can see these are the total images and exactly 3000 images per class. We have 340 categories, every image of 255 by 255 pixel. This is the dataset that I have made from the original dataset. And if you go here, you can see the dataset is pretty structured, right? So I have a master doodle data frame where I have like who have made it, the drawings, exact 3 points. But if I go to this doodle folder, I have a folder for everything. Inside a folder, I have Eiffel Tower class. Inside that, we have images of Eiffel Tower. Some of them will not look like Eiffel Tower, but they have the images. And this is why the model is also predicting. I was just drawing a bird. It was saying migration. Okay, so this is for Eiffel Tower. This is for airplane. This is for anvil. So eventually what you can do, if you can train a CNN based model on all these classes, you can also make your own game, right? Where people will, the person will draw and whatever the person is drawing on real time will check what are the class. If the class is matching from the random class I am making, so here comes the game. I can make a very simple model. And here you can see training the model on this data set is pretty easy because it's already pre-processed. The data is already there in a structured manner. Okay. And on top of that, I might have added a notebook as well. Have I added it? I've also added a notebook to explore doodles. So anyone who want to work on this data set and doodle classifier as well. Those who want to make a doodle classifier. So this is sample notebook. So to exploring doodle, I have mentioned like this is the code. this is sample code to load some of the images, and how you can draw it from the CSV file if you want to draw it. This is how each keystroke looks if you want to draw it. Okay, and that is from the CSV file. But if you want to save it as an image, this is how you can run the doodle classifier. Okay, eventually, just to make the things a bit clear to you, if you go to data card, inside this data card, this master classifier has these points. What are these points? These are keystrokes. Like there is a person who have started the arrow from there, go to these points and reach there. Then they have made a second arrow. Then they have made a third arrow or fourth keystroke. So these are drawing keystrokes. Okay, eventually these keystrokes are making the painting, making the drawing, but we need to write a code through which we can see how these keystroke looks. So to make the life easier for people, I have already written the code so that through the keystroke I will see the paintings, exact drawings. And that too, if you see, I have 1 million images, but the size of the data set is 5.5 GB. 5.5 GB. I have pre-processed it. Okay, so if you look closely, 5.5 GB for a million images, and I in actual data set has 50 times the images. So now if you look closely, the data set will be around 275 GBs. The original data set is very heavy. So what I've done to make the life easier for some of the people who want to work on that data set, I pre-process it and make it in my way. Okay, so this is one way of doing it. Along with that, you can also use, it's not, so this is basically just to show you, it's not like you need to always have a unique data set. You can also make life easier for people. Okay, so is there any model that can do speech to text for free? Speech to text, you can go to, again, you can go to Hugging Face, you will get model for almost everything. Okay, the result might not be as great as ChatGPT in text generation, that you can means you cannot get it from the open source model, but they will work. So search on the internet, you will get it. Okay, rapid API to extract data to and upload it on Kaggle. Yes, you can do that as well. So classifier who will classify or drawing the strokes on images. So a classifier will classify the drawing keystrokes of an image. That look, rather than going for keystrokes, drawing based on keystroke, from the keystroke make the drawing first, how the image exactly looks, and on that image make an AI model. That would be great. Okay, so this is about Doodle classifier. Eventually this is the notebook I'm uploading in probably 5 minutes on the on the reference page of the website, and that is it. Do you guys have any question? Do let me know. Suppose if we are fine tuning any model, so can you use someone else's model from Hugging Face, or you can publish it on Kaggle? Yes, for sure. Make sure to make sure to make it open with Creative Commons license. Okay, don't think of it as like you have made it by yourself. Like everything that is available on the internet comes with a license. Okay, so make sure to see like which kind of license they are using. If there is a proprietary license, there is a Creative Commons license. Creative Commons license, which most of the people are using on Kaggle or Hugging Face kind of platform, because they don't want because most of them are not making the models by themselves. They are like us. They are using a pre-trained model, fine-tuning it a little bit, and publishing it. So eventually, what will happen? They are not their own model, so they are using someone else's model, so their model can also be used by someone else. So that's basically the whole flow. Okay, so how to get the latest news on AI and stay updated about the data? uh get, like, there is no one such solution. Like, I'll get all the important details on my LinkedIn because my feed is like this. I'm modified like because of my history. But ARXIV, you can get the details there, but that is too, like, you need to invest a lot of time to reach there. So LinkedIn is something that will help you, but you need to make your account, and that way you need to follow the like-minded people who usually post about these things. Newsletters, yes, you can go to like deeplearning.ai newsletter. Yes, you can go ahead for that. Uh, and eventually AI न्यूज में इंडिया में क्या चल रहा है, दैट समथिंग. और व्हाट यू कैन डू, जस्ट मेक अ सिंपल चैट जीपीटी रैपर. ओके, चैट जीपीटी में सर्च इनेबल करो, have a separate chat where you'll ask, okay, what is recent AI news in India today? That's it. And because internet search is enabled, it will give you top 5 newses. That's it. Ask the AI again, it will give you top 10 news for tomorrow, means of the next day, so this is an easier way. But yes, eventually make your LinkedIn or your social media, like on my case, even on my Instagram, I'll get these kind of details because my algorithm is like, I have, like, because of fine tuning, not fine tuning the LLM, but fine tuning the, like, what I like to see, what I don't like to see. You can anytime go to any reel or any content and see it, pass it as not interested, and whatever things you like, pass it as interested. So that kind of content your algorithm will push. So even if in that case you are spending couple of hours on any social media app, you will not regret it, because eventually that's the information that you're getting, that's the betterment for yourself. Perplexity for news, yes, you can use Perplexity, you can use any LLM. With search enable, it will give you the answer. Okay, so what do you think about AI fluency? I don't understand your question. What do you mean by fluency? uh Sir, I get it. Even on Twitter, can't we have fun there as well? Yes, you can get it on Twitter. That's also fine. How did you go about creating the data and publishing in Cattle? How did we you go about creating? I've told you, I've taken a data set, I've pre-processed it, and then published it. In some cases, I've used web scraping as well, going to the internet, scraping some of the websites live data. And because live data, it's publicly available, so you can do it as well. So that's also a way of creating the data set. How can you start building this assignment from scratch? uh, what do we require to build it on our own? Uh, ASSG, what is this ASSG? You are talking about assignment from scratch. You don't need to build an assignment from this assignment from scratch. It's just about taking the model, already made model, generate the image, taking already trained image captioner, use it, have a proper documentation, publish it. That's it. Social media can be a great source to learn. Yes, but eventually you need to, it's very easy to get distracted. That's the problem. So make sure to modify your algorithm in the exact same way. Okay, what do you think about fluency? Could you please elaborate? I'm also not clear about what AI fluency you are talking about. If there's a new term, I might have missed. That's also quite possible. Can rise and track tabs. So how could you upload data set on Kaggle? And one he was asking what to park the question. Okay, how to upload your own data set? That's also pretty simple. First of all, you need to have the data set. Obviously, you need to have the data set first. Then go to Kaggle, click here, data set, upload your data set here. Once the data set uploaded, it will create a link, add a name, and once name is added, the portal will, your profile will look something like this. Your data set will be available something over here. And once it is here, you can go to model card, edit it, and edit the data details here. And then add all the different kind of details that are mentioned. Like here, you can also add each column name, each details, like what, from where you have taken the inspiration. These tags I need to manually add. These tags I need to manually add. I need to add these metadata, and I need to add this license manually. And eventually, you can check the stat. This stat is very powerful. As you can see, this data set is reached to 60,000 users. There are 8,000 people downloaded this data set. This is the big number, right? And they are top contributors. Okay, I don't know how like these people comes into contribution as well. Probably they have added the discussion or things like that. So like talking about, for example, this one is the data set that I have like these images are downloaded from Google. I've run a scraper that will go to Google's download the images, and inside this data set, this by far the most popular data set on my Kaggle. So this has 31,000 downloads, 1,40,000 views. Okay, so this is also a decent data set. So you guys can check these data sets out to get the reference. And for example, Mintra product dataset. This is the dataset of Kaggle dataset. This is a funny thing, but yes, this is what it is. I've not added a lot of details here, but this is the dataset of publicly available datasets on Kaggle. This is the dataset. These is the subtask. This is the author. This is the date of publish. This is the size of it. This are the number of upvotes. These are the number of views download. From here I can get how many data sets are there from a specific author, which author has published most number of data set, what is the biggest data set, what is the smallest data set, which author has most number of upvotes. So this is the data set on which you can do data analysis. Okay, but again, coming to the same point, I have not added a lot documentation on this that I should have added it, but eventually I'll add it someday.
Ashish, I have a couple of questions.
Hmm?
Maybe you missed it out in the chat. Yeah. So thing is, say suppose I'm working on company's data, right? I can't be basically exposing the data to this Hugging Faces models and all. Now, is it possible for me to download this model into one of a virtual machine in my org and host it, and then trigger the data using that model and get the output?
Yes, why not? Because eventually using transformers, I'm learning loading transformers on Colab.
Hmm.
You import transformers on your own system. It will download that model on your local system, and then the data will not be exposed to the API. It is exposed to the model, but the model is downloaded on your local system. So
Correct.
it's not going in someone's server. So you can use it for sure.
Okay. Now, other thing is Gemini, for an example, like it can do all these things within the same UI, right? Now, whereas right now we did see multiple models for individual kind of tasks, I can say. Whereas, how is Gemini alone able to do all the things together in a single UI? Is there some kind of agentic thing that is taking place for it to trigger that corresponding model and
It's it's a good question, first of all, and Nilesh has mentioned the answer as well. So there is a concept called as omni models or
Okay.
multi-models. So there are models that can do language to language, text to text tasks. There are models that can do text to image task, image to text task, image to image task. But we have some models. Companies are moving toward that direction where they will have an omni model. One model that can do image to text, text to image, image to audio, audio to video, everything.
Okay.
This is where companies are going right now. GPT-5 is one such omni model. Gemini 2.5 Pro, they are also kind of an omni models or multi-model in a better way, where they just don't have one modality. Modality means text to text, one model. Text to image, another modality, two models. So we companies are switching towards multi-model architecture, where one model can do multiple tasks.
Okay. Got
This
it.
is this is a basic description of it.
Got it. So single model can do all the kind of tasks.
An Omni model can do multiple modality. Yes.
Got it. Okay. And one last question. Thanks for your patience. Yeah. One last question. So say suppose I download one classification model from the internet. Can I do a bit of a training on my own data set and finally try to get an output based on my requirement rather than the generic classifications that we saw today?
Yes.
Okay.
This is like transfer learning, right? Using
Correct.
a pre-trained model, they are
Yeah.
pre-trained model. We can do fine tuning on them as well. We call it transfer learning. Yes, we can use transfer learning on these data sets as well.
Okay.
That's
Great
also
session.
that's also not that much difficult. That's also pretty easy.
Got
Thank
it. Great session. Thank you. Your knowledge is immense. Would love to get all the knowledge from you.
thank you so much. Thank you so much. It means a lot to me. So thank you so much everyone for joining us. My laptop is about to die. Just have 4% battery. So thank you so much for joining in, and I'll update this notebook in probably a couple of minutes. So I'll see you in the next session then. Take care. Bye. The assignment is ready, so you should thank me for sure. And okay. Thank you so much, everyone. Good night. Bye.